Okay, good morning. Welcome to
AwesomeMath163.
AwesomeMath163. So this is an exercise in the review problems from your area and perimeter section.
Yeah.
And the question is, how many different integers can possibly be the third side length of a triangle in which the other two sides have lengths 7 and 19? Do you understand this question?
Yeah.
You do? Okay, good.
So,
How would you like to proceed?
let's see. Well, if we have this side is 19 and this side 7, so this is 19. Well, we need to be sure, well, how far can we reach? So we need to, I think it's going to be any side, well, it has to be, I think it has to be, some of these two sides has to be bigger than 19.
Some of which two sides?
The sum of the two sides that are reaching together.
Oh,
Because
okay.
this is gonna, this might be an obtuse triangle.
You're right. I see.
So you need to, we can just make a list of how many work. Well, 1 doesn't work because 7 plus 1 is 8.
Uh-huh.
And then 2 doesn't work because 7 plus 2 is 9.
Yeah.
So then the one that will work, I think the first one that will work, I think it's going to be 12. 7 and 12, because 7 and 12 add up to 19.
Okay.
But, alright. 7 and 12 exactly add up to 19.
Ooh.
So 7 and 12 exactly add up to 19, so they're just going to be points on the line.
Uh-huh.
They're not going to be any elevated up from this line, so it's not technically going to be a triangle.
Yeah.
7 and 12 don't work. Well, 7 and 13 will.
Okay. So you think that's the first one that works? 13?
13.
Yeah.
So
Maybe afterwards we can go to Wolfram Alpha and see
Let's
what a
see.
7,
13,
13,
triangle.
19 triangle looks like.
So
Alright.
so that should be like that. It would be closer to the ground though.
Yeah, probably.
Well, the question is, how far can we go after this? Because we're not going to have infinite integers after that, which will work.
Right, give me an example of an integer that definitely is not going to work.
Well, maybe like 100.
Okay.
There can't be an 100 length side.
Why not?
Well, because it's going to stretch too far this way. And even if you stick it like all the way up, it'll stretch too far and the 7 can't reach.
Ah, okay. So some numbers are going to be too big.
Well, we have to find which numbers will be too big.
Which number is going to be too big?
12. 13 works. Well, how could we know when it'll get too big?
That's a good question. Sorry. Sorry for sneezing in the camera.
I'm not entirely sure how we could know how this would work.
But 100's too big, right?
Yeah, we know 100's too big.
How come 100's too big?
Well, it'll stretch way too far for the 7 to reach it.
Okay.
To reach the end point.
What do you think's going to happen when you get the number that's exactly the right size? Kind of like 12 was.
Well, I think it'll be a right triangle. Like a 7, 19 something triangle. And then 7 will be at a right angle.
At a right angle, you think that'll be the longest side line?
Probably. Because then it's just going to tilt it back and this side won't reach. Well, but you could always angle this side down again.
Oh, what would happen then?
So if this was pointed back like this, kind
Okay.
of.
Then it would.
You could angle the side down so
Yeah.
it could stretch longer.
Sorry, just pushing it back in camera. Could stretch longer. How long could it possibly stretch? What's the longest it could stretch?
Well, it could go down to the point where this is slightly angled.
Aha.
Because if it's completely flat, I'll just reach over that.
Right.
You have to make it.
So what's that like?
Well, it's going to be. Let's see. It's going to be. Oh, I think it's going to be 25.
How come?
Well, because 7 plus 19 is 26, and that's the length where it's completely flat.
Uh-huh.
But we're going up one. We're going up one.
Interesting.
So it's going to be 25.
So we might have a 19, 25, 7 triangle.
And that's the last one that will work. So it's 12, 25.
Wait, did 12 work though?
But 13 to 25,
Yeah.
and that's inclusive.
Yep. So how many numbers are there from 13 to 25
Well,
inclusive?
There's, there's going to be, I think 12 numbers.
How come?
Because it goes, so, you go,
Oh, you write them out.
okay, so 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25.
Right? How many numbers are there?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers.
How come there are 13, not 12?
Well, if you start from 13, that's 1, and then if you go to 13 to 23, that's going to be 11. It's going to be 11 numbers.
Okay.
And then there's 2 more, for 24 and 25.
Yeah, what's an easy sequence of numbers to count?
Well, if you just subtract 12 from everything,
There you go. You subtract 12 from everything and you got...
so it's a 1, 2, then 3, and it goes on till 25 minus 12 goes to 13.
There you go.
So it's 2 numbers.
Good job. Alright, you want to look at these triangles on Wolfram Alpha?
Sure.
Alright, let's do that.